Hello, this is Robert, and in this video I would like to discuss the difference between reference parameters and value parameters, and I'd also like to show you how to use the debugger. In this program I've set up two functions. One is called myFunction, the other one is main. And remember that all C++ programs have to have a main function, and execution always starts at the first line of main. Okay, then I've set up two integer values in main. One is called number1, and the other one is called number2. I would like to be able to see the memory addresses of my variables, number1 and number2. So I've set up these two pointer variables so that I can see the memory addresses for number1 and number2. You don't need to worry about pointers right now. The only reason I set them up is to see the memory addresses. Okay, then we have a function call right here to my function, and I'm passing number1 as the first actual parameter and number2 as the second actual parameter. Then I just output what number1 is and what number2 is. And on the previous run of this program, the output was 7 and 5. The values were initialized both to 5, but after we called my function right here, the output was 7 and 5, and we'll take a look at why. Okay, so this function call right here to my function just uses number1 and number2 as the actual parameters. Let's take a look at the formal parameter list right here up in my function. We have int reference ref number, and then we have int value number. Okay, so ref number is passed by reference and value number is passed by value. We know that it's passed by value because there's no ampersand right there, and so pass by value is the default for C++ functions. If there's an ampersand in front of the formal parameter name, then that makes it a reference parameter. Okay, I would like to see my program in action. So what I'm going to do is I'm going to do what's called setting a breakpoint. Right over here where the number list is, or in the margin if you don't have your line numbers turned on, you can click in the margin and then we'll get that little blue pointer right there, and that is what a breakpoint looks like in Xcode. In the second half of this video, I'll show you how to set a breakpoint in Visual Studio. Okay. After you set a breakpoint, if you would like to deactivate it, you can just left click on it one more time, and then it will kind of be grayed out like that. And then I can reactivate it by clicking on it again. If I would like to delete the breakpoint, I have to right click on it and select delete the breakpoint. Okay, now that I've set a breakpoint, it will stop the execution of my program right here, and it will allow me to see what the local variables contain, what values are going to be stored in number1 and number2. So let me go ahead and start the program. Okay, so we can tell by the green line right there that execution stopped on the function call. And so that is the statement that will be executed next. I would like to be able to see my local variables. And so what I can do is I can click on this little button right here in the lower right, and it's called Show the Variables View. So if I click on that, it opens up this window over here, and I get to see that number1 stores the value 5, number2 also stores the value 5. And then I have two pointer variables that contain the memory addresses of number1 and number2. So number1 is stored in memory, and this is a hexadecimal value, and the last three digits are 6D8. Number2 is stored at this hexadecimal value, and the last 3 digits are 6D4. Okay, so there are a couple of things that we can do now that we are in break mode. These little buttons right here allow me to continue the execution of the program. I can step over the line, which treats this one statement as a single statement. So even though it's a function call, I can treat it as if it's just a simple statement. Or I can click Step Into. If I click Step In, that will cause the execution of the program to jump to the definition of the function. So I'm going to go ahead and click that button. And keep in mind the values that we have down here for P and Q, 6D8, 6D4. So I'm going to click Step In, and notice that execution jumped up to the function right here. Okay, so when we did that, the local variables view down here changed to the variables that are inside of my function. So now I get to see what the address of ref number is, and I can see what the value of value number is. I can see that it's 5 right there. Let me step over this statement so that we get to see where in memory value number is. So I have val pointer or val p set to the address of value number. Okay, we can see that ref number contains the same address, 6D8, as number down here. So number 1 and ref number are both referencing or are associated with the same memory location. Number 1 had the value 6D8. Value number has a different memory location, 694. Remember that number 2 has the memory address 6D4. Okay, so we can see that value number has its own memory address, and number 2, as the second actual parameter right there, has its own memory location. So these are 2 separate variables. Since ref number is a reference, there is no separate memory location. It's actually a reference to the first actual parameter, number 1. Okay, so ref number and number 1 are sharing the same memory address. Remember that arguments in C++ are positional. So number 1 is first, ref number is first, and so that's why they go together. Number 2 is second, value number is second, and so that's why those go together. Pass by value means that the value of number 1, which is 5, is going to be stored in a separate memory location associated with value number. Number 1 here shares the same memory address as ref number because of this ampersand. It's a reference. I have created a graphic representation of this. Okay, so these values here, number 1 and number 2, they are in the main function and they are set to the values 5, right? When we call the function, we have reference parameter as our first formal parameter. Since that is a reference, it is referencing the memory location that is number 1. With value parameters, number 2 and then value param is a value parameter, and so the value of number 2 was copied into a separate memory location for value parameter. So there are 2 separate memory locations when you pass by value. Okay, let's switch back to Xcode. And let's step over this line right here. What we're doing is we're just adding 2 to ref number, and then we're going to add 2 to value number. So I'm going to click the Step Over button. And by the way, up here on the debug menu, those commands are all listed here. We have step over, step into, step out, etc. And we have some F key shortcuts here. So if I would like to use the F6 shortcut, I could use that to step over the line. It's a lot easier just to click the buttons right here. So I'd like to execute ref number equals ref number plus 2, and we should, okay, so if I open it up, we should see that the value is now 7 right there. And there it is right there. We added 2 to 5 to get 7. Then we're going to add 2 to value number. And so the 5 right here is going to go to 7. And it did. So now both ref number and value number store the value 7 because we added 2. Remember that they were 5 when we first called the function, then we added 2, so now they are 7. There's a big difference, though, in what the program actually did. Since value number has its own memory location, what we did was we changed the memory location of value parameter from 5 to 7. So now we have a 7 in our local formal parameter for my function. Over here, when we said ref param equals ref param plus 2, there is no local storage for the formal parameter. And whenever we change ref param, we are actually changing the actual parameter, which is number 1. Number 1 is back inside of main, right? So we're going to change this 5 right there to a 7. Notice that pass by value over here had no effect on the actual parameter up here. Okay, since it's a reference parameter, it changed the actual parameter when we added 2 to ref param. Okay, let's switch back to Xcode and see what we have next. We are at the end of my function, and so if I click step over one more time, we should see that execution jumps right back to main, and it's going to jump right back to the function call. So here is where it jumped. Here is where execution jumped to my function. And so when we reach the end of the function, execution jumps right back to there. Okay, so I'll step over it one more time. And now we can see that number 1 was changed to 7, right? Number 1 is the first actual parameter. And so anything we did to ref number, well, we added 2 to it. Anything we do to ref number inside of my function will actually make a change to number 1. Reference parameters make changes to the actual parameters. Number 2, well, we added 2 inside of the function. We added 2 to value number, but value number has its very own memory location, which is separate and apart from the actual parameter number 2. So when we added 2 to value parameter, it had no effect on number 2. And so that's why when we get back to the main function in Xcode right here, we can see that number 1 is 7 and number 2 is still 5. Because we added 2 to value number, it had its own memory location, so it had no effect on the actual parameter right there. If we step over this line one more time, and then the cout statement, we can see that the numbers are 7 and 5. Okay, I hope I didn't repeat myself too many times, and I hope I made it more clear than it was before. And in the next part of this video, I'll show you how to set breakpoints and go into break mode in Visual Studio. Okay, for the second part of this video, I'd like to show you how to enter break mode in Visual Studio. So I've set up a simple program here that has 2 functions, one called main and one called add them. This program is quite a bit simpler than the program that I set up in Xcode. I'm not going to be doing any reference parameters here. But I do have a prototype for this particular program. And the reason I need a prototype is because I decided to add the definition after the function call. So here is the function call in main, and you can see that the definition is below the function call right there. C++ is what we call a single pass compiler. So it only looks at our code once. So the compiler will analyze our comments first, and then it will include the IOStream library, and then it will look inside of the standard namespace to find the names of the functions and other items that we're going to be using. And then it's going to see this prototype. And notice that prototypes have semicolons at the end, whereas headers don't. So this is the header to the function, and there is no semicolon right there. In all other respects, the prototype is the same. You might notice, though, that I don't have the names of the formal parameters. Let me go ahead and put them in. So then we can see that the prototype is exactly like the header, except the prototype has a semicolon at the end. Okay, so since C++ is a single pass compiler, it's going to see this function call before it sees the function definition down here. So if we don't have the prototype here, there's no way for C++ to know that we are using this function add them in the correct way. The single pass compiler will not know what add them is, and it will not know if we're using the right number of arguments or the right data types for our arguments. So int and int, right? Okay, so by adding a prototype, it's sort of like letting the compiler know that there will be a function definition somewhere later on in the code. And so if the compiler sees a call to a function called add them, it can check for correctness because the prototype has the name of the function and it has the formal parameter list. So the compiler will know that a call to add them should have 2 integers as the actual parameters. And so we have an int for number 1 and an int for number 2. Okay, you might have noticed that I left off the names right here, and so I can do that because the prototype still contains enough information to check for program correctness. We have the name, and we know that the first argument should be an int, and the second argument should be an int. We have to have the names of the formal parameters inside of the header, because if we don't, then we won't be able to manipulate those values. So these are not optional in the header. This is the header of the function definition. It's the first line of the function. All right, I would like to be able to see my program in action. So what I'm going to do is set a breakpoint right on the statement where my function call is. So I'm going to move over to the margin over here, and I'm going to click there to set a breakpoint. If I would like to remove it, all I have to do is click again. Okay, now that I have a breakpoint right there, when I start up my program, execution will pause when it reaches that statement. And I'll be able to see the values of my variables once it starts up. The values of the variables appear in the autos window. And so if I click on autos down here, I can see that number 1 contains 5, number 2 contains 7, and at this point, result is undefined, and so we see that really big negative number right there. That's the value that Windows placed inside of result. And since we didn't initialize it, or I didn't initialize it right there, it doesn't contain any value that I set it to. Okay, so here's my breakpoint, and you can also see that there's a little yellow arrow right there, and that little yellow arrow is pointing at the next statement that will be executed. Just like with Xcode, I can step into a function through the function call. I can step over it as if it's a single statement, and then I can step out. These are the buttons up here. So this is step in, this is step over, and this is step out. So F10 is for step over, and then F11 is the shortcut for step in. I would like to see the function in action, so I'm going to click step in, and execution jumped down to the first line of the function. So there's the little yellow arrow pointing at the first statement of add them. And so I'll step over one more line. So I'm going to click step over this time. And I'm going to click on autos down here, and I can see that num1 and num2 are my local variables for add them. And then we have another variable called result. Well, we have a result here, and we have a result up here. These are two separate variables. This result is local to add them. This result is local to main. So these are two separate variables with their own separate memory locations for storage. Okay, we are on this line right here, this statement, result equals num1 plus num2. And so if I step over that line, we will be able to see that result will be set to 5 plus 7, or 12. So I'll step over it and go back to autos, and we can see that result is now 12. And whenever a statement makes a change to a variable, the value will turn red. So the previous statement, result equals num1 plus num2, changed the variable result, and so now it's red right there. Now we are on return result. So let's step over this one more time. And then we're going to return back to the call when we reach the end of the function definition. So we return right back to the function call add them. So now we are back to the locals for main. Okay, so add them returned the value 12, and then we have result on the left side of an assignment statement right there. And so when we step over that value 12 will be stored in result. Okay, so step over one more time, and now we can see that result stores the value that was returned from add them. And so result now stores the value 12 right there. Okay, and then if we step over it one more time, I can switch back to my executing program, and we can see that the output there, or we should be able to see it, there it is, result is 12. Okay, so then if I step over it one more time, we can see the press any key to continue right there, and then the program will be terminated. Okay, so return 0 in main causes causes the program to terminate. I could also just click continue right here, and that will continue the execution of the program and terminate it normally. Okay, so that is how you can set a breakpoint and see the execution of your code using Visual Studio. Thanks a lot.